Good afternoon, everyone. I'm so happy to see such an amazing participation and would like to thank you all for attending this webinar. And thank you all for your time. So before we start, first of all, let me introduce you a little bit about this webinar series. I'm sure most of the people here are regular participants. However, there might be some people who must be joining in for the first time. So I welcome you as well. So this webinar series is a part of the project, the Electric Mobility Forum, funded by our kind supporters, the Shakti Sustainable Foundation. The project was launched by the Vice President of India on the 28th of March 2019. So, as a part of this project, we organize various webinars on very crucial topics revolving around electric mobility, along with, of course, many other activities such as workshops, opinion pieces, blogs, newsletters, etc. So regarding the webinar series, we successfully completed many such series with such important topics. For example, I'm sure you must have already attended standardization, impact of electric vehicles charging on local grid, retrofitting, and such important topics. So, so far we have been doing this on a very focused topic and received wide interest and participation from all over the world, actually, not only India, and from all kinds of like EV industries, starting from like academia, policymakers, government organizations, manufacturers, operators, and you just name it, we have it. So this time we have a very, very special topic, which I think it's very important for me as well personally, if I want to own an EV vehicle, whatever mode it is in the future. So the topic this time is testing and accreditation of status of electric vehicles in India. Okay, so now why this topic, out of so many? So we all know that the issue of air quality around the globe and many countries, including India, have made promises in terms of policies and products to tackle the rising problem of, air quality. 23% of the global GHG emissions are from the transport sector, and 70% of these emissions come from cities, which has a lot of them vehicles in them, like new or old, doesn't matter, but they come from all these vehicles in the cities. Air pollution linked to 6.7 deaths worldwide, along with many diseases such as respiratory problems, lung cancer, etc. So out of many sustainable ways, electrification of transport is one of the mediums to tackle the problem of air quality. Although there have been many efforts in the country in terms of like policies and incentives, etc., to promote these vehicles, there are still some major anxieties or confusions when it comes to the adoption of electric vehicles in our respective cities and states. So these kind of confusions act as a speed breaker in the adoption of this new technology. Now, one such confusion is regarding testing and accreditation of electric vehicles based on their type, their mode, what kind of technology. People might be having questions like, okay, I have this vehicle, so, where do we go for testing? What kind of tests are they? And many, many such questions. Especially, I think it is important for the research and academia and also the startups who have brilliant, innovative ideas regarding new modes of transportation, obviously with electrification in, focus. Now, with electric mobility emerging as one of the most prominent measures to tackle climate change, it is important to keep in mind the special characteristics of the Indian context. So, learning from Western countries is a great thing. However, we have special qualities and issues in India for which we might want to have like our own solutions, homemade, custom made. So understanding the kind of testing and accreditation measures required to ensure maximum efficiency of the product can be tricky when it comes to matters such as battery safety testing, battery failure analysis, battery and vehicle performance testing, battery fire and abuse testing, etc., and many more. Hence, in this webinar, we have a very significant guest, Mr. Anand Deshpande, who has been working with ARAI, and he is an expert in this matter. So we have, requested him to throw us some light on this like key topics regarding standardization. Testing of electric vehicles in the Indian context, and what is the status, where do we need to go, etc., etc. The key questions are already mentioned in the registration link for which you have registered already. So I won't take much time by repeating them again. But however, when before starting, I would like to mention some of the key important points. That is, this is a 1 hour session, and it has one presentation by Mr. Deshpande followed by question answers. So I would request you to keep on sending me as many as questions as possible in the questions box and not in the chat box. Okay. And so, like, even if we don't cover this in the end of during the course of this webinar, due to obviously time constraints, we will try to address them as a knowledge product later on. I'll be uploading it in the same link. Now, the last thing is that I know even I do that, so I would request you not to take notes or click pictures and waste time, and put your 100% attention in this webinar, which is going to be live, because the good thing is that we'll be having the materials in terms of the presentation and the video uploaded in the same link, in the same link where you have registered. We'll be following up the question answers later once Mr. Deshpande does his presentation, and I welcome you once again, and I hope that this topic must be as fruitful and knowledgeable as it is to me. So handing it over to Mr. Deshpande, welcome.
So good afternoon. Good afternoon, everybody. Thank you, Shravani. Am I audible and I am visible, my presentation?
Yes, sir, we're doing just fine. Yeah.
Now I will put my presentation into slideshow mode. Yeah. So is it visible?
Yes, sir, it is.
Okay. So good afternoon, everybody. It is nice talking to you on this important subject of testing and accreditation or approval of electric vehicles in India. So I am from ARI, as Shravani mentioned, and I will take you through some of the background about the standardization efforts, government policies, what are the test standards required, what typically the testing of electric vehicles is required, what are the challenges facing the electric vehicle development, and so forth, and how at ARI, in short, we can support the industry in overcoming these challenges. So let me start with the first slide. As you know, Mr. Tony Seba is a renowned author and Stanford University professor, and he has done a lot of forecasts, and it is seen that his forecasts are becoming true. He has forecasted that by 2030 there is going to be clean disruption of energy and transportation in the world. So what he says that all new energy will be provided by solar and wind, all new cars will be electric vehicles, all of these cars will be autonomous, probably in Western world, not in our country, but then individual car ownership model will be obsolete, new car market will shrink by 80%, mobility will evolve as a service. As you know, we are seeing all these trends actually happening to some extent, and the world is moving in that direction. In India also nowadays, already auto industry is facing some kind of disruption in terms of sales. Also, personally, we are more relying on shared mobility using Ola and Uber. Electric vehicles also government is quite a bit focusing, and government is also focusing on renewable sources of energy for our transportation as well as for our daily use. So these forecasts are to some extent becoming true, and in future those may be really true. On this background, what is the global scenario in terms of electric vehicles, how it is evolving? The International Energy Agency, they publish every year, they publish the report, and in the last year the passenger car, electric passenger car numbers crossed 5 million mark. In the last 1 year itself, 1 million passenger cars were added to the global stock. Various countries such as Norway, Netherlands, Germany, France, UK, they have set targets to go full electric by 2030 or by 2040. Last week there was the news that Denmark has already proposed to European Union that European Union should define certain time target to go for electric transportation. India, as our country, government has increased focus on electrification of transportation. Initially, we were talking about some target, but now the government is saying that government is encouraging and focusing on electrification of transportation. Various vehicle manufacturers like Volvo, Daimler, Volkswagen, they have announced plans to go for electric powertrain. They will develop only electric powertrain in future. They will be less working on internal combustion engine powertrain. Then IEA, International Energy Agency, has forecasted that by 2025 there could be 70 million electric cars on the road which will be running. And World Bank also has announced that it will stop financing upstream oil and gas projects after this year, and instead they will fund towards clean energy projects. So these are the global trends which are happening, and every day, every week we are getting new news, and probably you will be also coming across such trends. Uh, electric buses are becoming quite popular also worldwide. So global electric buses also, they reach around 4,60,000 buses on the road in last year. Out of that, China is leading the way. 99% of electric buses are in China. Shenzhen in China is the first city in the world where 100% electric bus fleet is operating. Around 16,000 buses are running on the roads in Shenzhen city. Other countries in Europe, Netherlands, Latin America, USA, and in India also, a lot of buses are being introduced into the market. Schiphol Airport in Amsterdam, they are operating 100 electric buses. In India, under FAME India scheme, first phase, around 390 buses were funded, and those buses are running in pilot mode in various cities. And in phase 2 of the FAME India scheme, around 5,595, that is 5,600 buses have been sanctioned already by the government in 64 cities to be operated by municipal corporations or state road undertakings. And now those municipal bodies or STUs, they are in the process of floating tenders. So this is how in the bus segment also it is evolving. Now coming to the initiatives by Government of India, Niti Aayog, our government's think tank, which works on the policy for Government of India, they published a report 2 years back, which is India Leaps Ahead Transformative Mobility Solutions for All. And in this report, Niti Aayog has predicted what is going to be the future of mobility in our country. And they have predicted that the future of mobility is going to be shared, electric, and connected. And because of that, we can reduce 64% transportation related energy demand and 37% carbon emissions by adopting shared, connected, and electric mobility. Now, why our government is focusing on electric mobility? These are the driving factors. As Shravani was mentioning in our initial remarks, India is signatory to Paris Climate Change Agreement. So, as our commitment, national commitment to this climate change agreement, we are focusing on electric mobility. Our ambient air quality concerns. Out of 20 most polluted cities in the world, 14 cities are in India. So this is a quite concern for the Indian government. The major important factor is our import of oil. We are highly dependent on imported fuel, that is petrol and diesel. Around 80% of our fuel demand is imported, and we are spending around $80 billion every year. And it is expected that by 2025 our foreign exchange expenditure bill will reach $150 billion. So it is very critical for our economy and also for the treasury of the government. So from the energy security point of view, we have to reduce the import of oil. And the fourth important point is thrust of government on solar power generation and storage. As you know, in India, we are abundant in solar. We are almost 9 to 10 months of the year, we have got full sun, and we are abundant of sunlight. So if we can harness the solar energy and we can store that energy in energy storage in batteries, we can fulfill our energy demand not only for our domestic and industrial purposes but also for transportation needs. So electric vehicles with their onboard batteries, they provide mobile storage of solar energy. So we can generate power in a clean way, and we can also utilize the power in a clean way in the electric vehicle. So these are the main four factors because of which government is focusing on electric mobility. Now, what is the government's plan? In the year 2013, Government of India launched National Electric Mobility Mission Plan, that is NAMPP. And under that, Government of India launched Faster Adoption and Manufacturing of Electric Vehicles, that is FAME India scheme. The first phase of the FAME India scheme, it had four focus areas, that is technology development, demand creation, pilot projects, and charging infrastructure. Government is quite concerned about development of local technology, then creating demand internally so that consumers are attracted to buy electric vehicles by giving incentives and various benefits, then rolling out pilot projects in various cities so that awareness is created, and also creating charging infrastructure so that the consumers are not suffered in the field for charging of electric vehicles. This phase one of FAME India scheme was launched in the March 2015 with effect from 1st April 2015, and it concluded on 31st March 2019. So it was on for 4 years, and the outlay which was allocated for this phase one was 895 crores. And under this phase one, government had lot of feedback and lot of learnings from a lot of suggestions from the industry and R&D organizations. And based on that, Government of India launched phase two of FAME India scheme, that is FAME 2. Now this phase 2 is started from 1st April 2019, and it is for a 3-year period, and it has got three components. Again, demand incentives for the purchasers of electric vehicles, establishment of charging stations, and administration of the scheme. But the important point is that the fund allocation for phase 2 is 10 times increase, that is 10,000 crores as compared to phase 1. So out of 10,000 crore, around 8,006 crores have been allocated to demand incentives. Around 1,000 crores have been allocated to charging infrastructure, and rest of the funds are allocated for administrative expenses and also some portion of phase 1. So this is a very ambitious scheme of the Government of India to kickstart electric mobility in the country. Now, under these are the typical features of FAME India scheme phase 2. The important objective is to create demand by reducing the acquisition cost of electric vehicles by giving incentives. Then vehicles fitted with advanced batteries like lithium ion and other chemistry batteries, lead acid batteries will not be eligible for FAME India scheme. Then demand incentive amount is directly proportional to the battery capacity in kilowatt hour. It is rupees 10,000 per kilowatt hour for all vehicles except buses, and for buses it is rupees 20,000 per kilowatt hour. Similarly, there is a major emphasis on public transport. So the applicable categories which are covered under the scheme are buses, three-wheelers, taxis, and two-wheelers. In case of two-wheelers, even personal two-wheelers can get the benefit of demand incentive. The important thing to note here is that government expects that initially the penetration of electric mobility will be in the public segment, public transportation segment. The consumers will travel in public transport mode. They will travel in the bus, they will travel in the taxi, they will travel in the auto rickshaw or e-rickshaw. and they will have the first-hand feedback. Their concerns about range, safety will be addressed, and then they will be attracted to buy electric vehicles for their personal vehicles as choice. So that's why there is a major focus on public transportation. Now these are the fund allocation for various categories of vehicles. For two-wheelers, 10 lakh two-wheelers will be financed under same scheme. So it will be around 2,000 crores rupees. Then three-wheelers, including rickshaws, around 5 lakh three-wheelers. It will be around 2,500 crores. Four-wheeler taxis, 35,000 taxis, around 525 crores. Four-wheeler taxis, hybrid vehicles, strong hybrid vehicles, around 26 crores. And buses, around 7,000 buses, uh, amounting to 3,500 crores. Out of that, already 6,500 buses have been sanctioned. So this is in short about the fund allocation across various vehicle segments. Typically, the incentive applicable to various vehicle categories are like two-wheelers. Typically, two-wheeler uses 2 kilowatt hour battery, so it will be around 20,000 rupees. Three-wheelers, it will be around, if it is a 5 kilowatt hour battery, it will be around 50,000 rupees. Passenger cars and light commercial vehicles, if they use 15 kilowatt hour battery, then it will be 1.5 lakhs. And buses, uh, it will be around 50 lakhs maximum cap on the bus. But here the difference is that the incentive will be given not on the capex model but on the opex model of the bus, so that the municipal corporations or the state transport undertaking, they will lease the buses, they will get the buses on lease mode, and they will pay to the bus operator on the monthly basis, and they will get the reimbursement of the lease charges from the government as a part of incentive. So these are the incentives, direct benefits which are available to the purchasers of electric vehicles. Then there are additional financial benefits like GST. GST as applicable to the electric vehicles is at 5%. It is the most discounted GST rate, tax rate for the electric vehicles, because normal conventional vehicles, even a two-wheeler or a three-wheeler, has got a GST of 28%. And for bigger four-wheeler sedan vehicles or high-end four-wheeler vehicles or hybrid vehicles, the GST goes on up to 45%. So there is a direct minimum discount of 23% in GST for purchase of electric vehicles. And this GST is common across two-wheelers to buses. So there is a major boost in terms of GST for the electric vehicles. Additionally, government has announced in the recent budget there is a income tax deduction up to rupees 1.5 lakhs on interest component of electric vehicle loan by the purchaser. It is similar to the home loan. Suppose we buy a home loan, we buy a home and we take a loan, then on the interest component we get direct deduction in our income, so that we get rebate on income tax. Similarly, if any purchaser purchases electric two-wheeler or a four-wheeler and he gets it on loan, then the interest component is directly deducted from the income, so that there is a tax benefit. Additionally, various state governments, they have also announced their EV policies, and under that, those EV policies, they are waiving road registration tax, road tax, and some of the states are additionally giving demand incentive or financial incentive in addition to FAME incentive. For example, in Maharashtra, there is an additional incentive given to the purchaser of electric vehicle. So, as I was mentioning, state governments are also formulating state-specific EV policies like Maharashtra, Karnataka, Telangana, Andhra Pradesh. Recently, UP also has announced, Goa has announced. So these states are giving, in addition to financial benefits, they are inviting industries to invest into their states for setting up electric vehicle manufacturing plant, battery manufacturing plant, charger manufacturing plant, and they are giving a lot of benefits. These are all fiscal benefits. In addition to that, there are some non-fiscal benefits which are not mentioned in the slide, but I will explain to you. Uh, uh, Various states, they have central government at the request or at the advisory of central government, Ministry of Road Transport, they have waived the permit fees or permit requirements for the auto rickshaws if those are electric. So any person who has got electric auto rickshaw, he can easily get a permit without permit fee or without permit quota. Similarly, uh, any the license for to drive the vehicle can be obtained when one attains the age of 18 years. But any any kid who has attained the age of 16, he can get the he or she can get the driving license if that person is having electric vehicle or of certain maximum speed and maximum power. So if the electric two-wheeler of maximum speed of 70 kmph or maximum power of 4 kilowatt, the person, the kid can get the license at the age of 16. So this is a big boost, and there is a big demand or a big pool of customers who are requiring transportation need for going to their college or tuition classes and for their activities, and those could be the probable customers for initial customers for the electric vehicle. So this is how government is encouraging proliferation of electric vehicles in the country. Similarly, government is about very serious about establishment of charging stations. Of course, as you know, electric vehicles are quite comfortable. You can charge the electric vehicle at your convenience, at your home or at your office. We get ample time at our home or office where we can plug into any plug point and we can charge the vehicle. But additionally, if someone runs out of charge on the road or while travel, there will be charging stations which will be installed on the main roads, in the multiplex malls, in the movie theater complexes, on the highways, wherein the consumers will be able to get chance to charge their vehicles. So under FAME India scheme, government has allocated 1,000 crores, and government of India's Ministry of Heavy Industry has already uh, invited proposals from various cities and various state governments to set up charging stations in their states. Now coming to the same, the vehicle manufacturer develops an electric vehicle, whether it is a two-wheeler, three-wheeler car, or a bus, how it will become eligible to get incentive under FAME India scheme. So the basic requirement for eligibility for FAME India scheme is that the vehicle should be type approved as per Central Motor Vehicle Rules, that is CMVR. And Central Motor Vehicle Rules are notified under Motor Vehicle Act, and those are notified by Ministry of Road Transport and Highways. And this is the ministry which is the nodal ministry for regulating the approval of all types of vehicles, including electric vehicles, which are running on the road. Once the vehicle has got type approval as per CMVR, then that vehicle can be registered at the local RTO office, and it can be run on the road. So the basic requirement to avail FAME India scheme incentive is that the vehicle should be type approved as per CMVR. So when any vehicle manufacturer approaches ARI, our institute, because we are also authorized by the Ministry of Road Transport and Highways to approve the vehicles for CMVR, and we are approved by the government to do FAME eligibility assessment. So we initially check their type approval. Then there is upper cap on the ex-factory price, because the government intends that very high-end vehicles or very luxurious vehicles cannot be supported under FAME India scheme. So there is an upper cap on the price of the vehicle which has been prescribed under FAME India scheme. Typically, if it is a passenger car, it is a 15 lakhs. If it is a two-wheeler, it is 1.5 lakhs, and if it is a three-wheeler, it is 5 lakhs, and for bus it is 2 crores. So the price of the ex factory price should be less than the upper cap price. Then government has announced a localization requirement. That means, as you know, today the vehicle manufacturers are importing components required for the electric vehicles, but the vehicle manufacturers are required to locally manufacture those components. So government has announced a roadmap for localization of critical electric vehicle components. So they have to comply with the localization requirement. Then the manufacturers have to give battery warranty minimum 3 years, and they should have facilities for after sales service, and also it should be intended for public and commercial transport. Then there is a technical assessment. We verify whether the battery is of advanced battery type. It is not lead acid battery. What is the battery density? What is the life cycle of the battery? Then there is a requirement of monitoring device in the vehicle, so that in future government intends that the actual running of the electric vehicle data will be captured onto a server, and government will come to know each vehicle how much distance it has traveled, and they will get the information about the benefits of funding the electric vehicles. Then electric vehicles should have electric regenerative braking system. So these are the technical assessment. Then there are performance parameters. Uh, Importantly, range, it should qualify the minimum range requirement. So there are range requirements for different categories of vehicles. Energy or fuel consumption in case of hybrid vehicles, it should meet the energy consumption requirement. It should have minimum maximum speed. It should not be a very low speed vehicle. It should have minimum maximum speed, minimum acceleration. It should be able to climb a gradient. It should be able to climb a flyover, and there will be a measurement of energy content or battery capacity, because incentive is determined based on the battery capacity. So these are the performance parameters. Then there are requirements for eligibility certificate. The vehicle is required to be fitted with a sticker, which is defined by the government to promote the FAME India scheme. Then the OEM is required to register under the scheme with the ministry, and there is a cap on the maximum amount of incentive, which is 20% of minimum ex-showroom price, and registration as motor vehicle as per CMVR. So these are the various features or the parameters for becoming eligible for FAME India scheme. And when any vehicle manufacturer approaches ARAI for FAME eligibility assessment, we take that model and their application through all the checks, and after that we issue them the FAME eligibility certificate. Now this is the phase manufacturing program, that is PMP, which is issued by the government, Ministry of Heavy Industry, and it is category wise: electric two-wheeler, three-wheeler, e-rickshaw, auto rickshaw, four-wheeler. M1 is passenger vehicle, N1 is goods vehicle, and buses. M2 and M3 are small buses, midi buses, and M3 are 12-meter buses. So government has given a roadmap up to 2021, April 2021, and various critical components of electric vehicles like HVAC, because in electric vehicle air conditioning system also operates on electric compressor, then AC charging inlet, battery pack, DC-DC converter, electronic throttle, vehicle controller, onboard charger, traction motor. So all these important components of the electric vehicles, suppose initially those are imported, but when they should be localized, when they should be locally manufactured, that timeline has been prescribed by the government, and all the manufacturers have to comply with the phase manufacturing program for the localization. So this is also issued by the government, and we are checking all the models as per this PMP program. Then coming to how one can see that how electric vehicle program is evolving in our country. As I was explaining, in India, government is focusing on electrification of transportation. There is an increased focus on penetration of electric vehicle in public transport. That's why major focus is on e-rickshaws, autos, taxis, and buses. Slowly, two-wheelers and passenger cars also will become popular. strategy, one of the strategy government adopted was aggregation of demand, wherein ESL, you probably might be aware that Energy Efficiency Services Limited, that is a government company under Ministry of Power, they uh, they floated tender for 10,000 electric cars and 2,000 chargers for the use of government departments, and they are procuring these vehicles for the use of various officers and executives in the various ministries and government departments. They are also providing these vehicles to various state government officials also. And one can see establishment of charging stations in various government buildings in some of the roadside areas in Delhi. I could see in certain parking areas there are charging stations which are coming on major highways or expressways. They are coming. Then the Department of Heavy Industry has floated expression of interest for municipal corporations and state transport undertakings for electric bus operation and public charging stations. And already the electric bus sanctions have been already approved, and those cities have been already notified for going ahead with the tenders. Similarly, public charging stations expression of interest is in the process, and soon DHI will announce which are the cities which have or which are the projects they are going to provide funding under FAME India scheme. Then Department of Heavy Industry has done standardization of tender specifications for electric buses, because in FAME 1 scheme there was a lot of confusion about various states and various corporations coming out with different tender specifications. Some of the tenders got cancelled. So DHI has done standardization of tender specifications, which will act as a guideline document for the individual states to float tenders. Similarly, Niti Aayog has drafted model concession agreement for procuring electric buses by the cities on OPEX model. This will also serve as a kind of a guideline document for the cities to float tenders. So this is how electric vehicle program is panning out. We are seeing every week there are new companies, new startup companies. In this week also Bajaj also announced their electric two-wheeler Chetak. There was a grand function in Delhi wherein they launched their electric two-wheeler. Similarly, other manufacturers are also bringing their electric vehicle models. So what we are seeing is that there are different innovative business models which are also coming. It is not a conventional business model like OEM. We are having a manufacturing plant, we are having a dealer network, and there is a conventional vehicle sale. In electric vehicles, there are different innovative business models are also coming up. Like there is a talk about swappable battery versus fixed battery, wherein the consumer is not required to charge the battery. The consumer can go to a swapping station, he can give the discharge battery and he will get a new charge battery, and the swapping station will have a bulk lot of batteries, and they will do bulk charging of the batteries. So this is an innovative business model. It is like our gas cylinders, household gas cylinders, wherein we give our empty gas cylinder and we get a filled cylinder. Similarly, city electric bus fleet on OPEX model. This is also an innovative business model wherein initial cost of bus is very exorbitant. So buses are not procured on CAPEX model, but those are procured on OPEX model, and running cost of buses, electric buses, is quite economical. So OPEX model proves to be economical considering that initial cost is higher. Similarly, multimodal electric transportation solutions are coming up, wherein lot of cities are coming up with metro operations. So the feeder vehicles like e-rickshaws, auto rickshaws, taxis, which will take the passengers to the nearest metro station from their homes or from their offices, will be electric. So it will be all electric kind of multimodal transportation. Metro is electric and feeder vehicles are also electric. Then there are electric shared fleet like Ola, Uber. They are also converting some of their fleets. Ola is working on electric auto rickshaws. they had a pilot project in Nagpur where they had electric auto rickshaws and electric taxis also. Similarly, e-commerce companies, or where they are having their delivery vehicles, they are using electric fleets, because most of the time the operation is start-stop operation, and electric vehicles are quite suited for such kind of application. Similarly, electric retrofitment is also coming up, wherein old vehicles which are running on the road, which are of old vintage, which are polluting, which are consuming a lot of fuel because the engine has aged and it has degraded. Such vehicles can be converted to electric by removing the engine and by putting an electric motor and battery. So startup companies are coming up wherein they are developing electric kit and converting existing vehicles. So these are the various innovative business models also which are coming up, and all of them have got bright future. Only time will tell how it will evolve. Now, coming to the main topic of our today's webinar, that is electric vehicle standardization. I will briefly touch upon how the electric vehicle standards are there, how the vehicles are approved, what are the tests we are carried out at our laboratories. So, coming to the standardization, this is a matrix of various standards which are applicable for electric vehicles for under central motor vehicle rules. So, for electric vehicles, uh, AIS stands for Automotive Industry Standard. So there are standards like AIS 38, 39, 40, 41, and 49. These are electric vehicle specific standards in addition to normal conventional vehicle standards. Then for hybrid electric vehicles, there is a separate standard, that is AIS 102, Part 1 and Part 2. Then for retrofitment, that is for converting existing vehicle to hybrid vehicle or electric vehicle, there is a standard AIS 123. Then for charging stations, there is a standard AIS 138, and recently Bureau of Indian Standard is also working on developing standards for electric charging stations, and the standard is IS 17017, which is similar to AIS 138. Then for small series, if some OEM wants to introduce pilot number of vehicles on small numbers, then there is a standard AIS 131. For low speed two-wheelers where the speed is less than 25 kmph, there is a specific set of requirements which is notified under notification GSR 291. Then for e-rickshaws, there are separate notifications under CMVR for the technical requirements. And for battery, there is a dedicated safety standard AIS 48. So this is a regulatory framework for the electric and hybrid vehicles. I will briefly tell you about what are these standards about. For the electric vehicles, these are the standards AIS 038, as I was mentioning. This standard talks about construction and functional safety. As you know, in electric vehicles, we are carrying onboard electricity. Some vehicles will have around 48 volts, some vehicles will have 72 volts, some vehicles will have 300 volts on board. So the driver, the passengers, these users of this vehicle, they should not have any kind of shock hazard. So these vehicles should be electrically safe. So for that purpose, there is a dedicated standard for construction and functional safety, so that it is safe for the users. Also, additionally, under this standard, there are separate requirements for safety of electric vehicles in terms of water tests, because like a normal vehicle, the consumer will wash the vehicle. There will be rain outside in the monsoon, there will be flooding on the roads, and the electric vehicle will be driven in the water clogged condition. So under that also, the electric vehicle should be safe and it should not have any kind of electric shock. So all those requirements are verified under the requirements of AIS 38. Coming to the AIS 39, we measure electric energy consumption. Like a conventional vehicle, we have fuel consumption certification, means how much kilometers per liter certification is done for a conventional vehicle. For electric vehicle, the energy is electrical. So electrical energy consumption in watt hour per kilometer is measured and it is reported. This parameter gives the economy figure for the consumer, and he comes to know per kilometer how much money he has to spend. Similarly, range is important parameter for electric vehicles. So AS040 standard specifies the method to measure the range of the electric vehicle. So in one charge, how much distance the electric vehicle will travel is measured under this test. Like a conventional vehicle, we measure, as you know, we have got the bhp rating of the conventional vehicle. It is like 50 bhp or 100 bhp engine in the conventional vehicle. Similarly, in case of electric vehicle, there is a kilowatt rating for the electric motor. So whether it is a 5 kilowatt or 50 kilowatt or 100 kilowatt or 250 kilowatt motor which is used in the electric vehicle, that electric motor power is measured using the method or the test procedures prescribed in AS041, and that is certified. Similarly, there are requirements like conventional vehicles. The electric vehicle are required to meet the requirements for braking, for the lighting system, for the gradability, then uh, sound level. So all these requirements, because electric vehicle, apart from electric powertrain, it is like a conventional vehicle. So all other requirements of electric vehicles are as compared to internal combustion vehicles are captured in AS049 standard, and the compliance is verified as per the standard. Then the last one standard is AS048. This standard specifies the safety requirements for traction battery. Because battery, as you know, nowadays, those are mostly lithium-ion batteries and those are high-energy batteries. And lithium-ion batteries are notorious for fires if those are not properly handled, if there is no battery management system. So if there is any kind of a thermal event occurring inside the battery, it can lead to a fire. So all types of battery safety tests are carried out to verify that the battery is safe for operation in the electric vehicle. And all such tests are carried out under the compliance for AS048 standard. So this is how these are the various standards in addition to the normal standards for braking or lighting system or horns or mirrors, like conventional vehicles, which are carried out on the electric vehicles to make sure that these electric vehicles are roadworthy and those can be safely driven on the road. Then there is a global technical regulation, GTR 20, on electric vehicle safety is getting developed at the international level. India as a country is signatory to GTR 20 regulation. From India, we are participating in the standardization effort, and we are aligning our standards or amending our standards in line with global regulation. And this standard talks about shock protection, unintentional vehicle movement, low energy stranding, RESS, that is battery rupture, toxic gas management, battery installation and protection, elimination, mitigation of potential thermal explosive event. So all such scenarios are handled in the standard. Then coming to the hybrid electric vehicles, there is a standard AS102. The part 1 is for the hybrid vehicles for passenger cars with vehicle weight less than 3,500 kg, and part 2 for vehicles more than 3,500 kg, that is trucks and buses. So these standards are also developed in line with UNEC regulations, and here also electrical safety is verified. Then because there is an engine, so there are requirements for exhaust emissions, there are requirements for fuel consumption like conventional vehicles, and the compliance is given to the hybrid vehicles. Then coming to the retrofitment regulations, there is a standard, dedicated standard AS123, and there are 3 parts. Part 1 is for conversion of existing vehicles into hybrid vehicles for passenger cars or 2-wheelers and 3-wheelers up to 3,500 kg, wherein engine is retained and electric motor and battery is fitted. Similarly, part 2 is for converting existing vehicles more than 3,500 kg by retaining the engine and putting a motor and battery. And part 3 is for pure electric conversion, wherein engine is removed and high power motor and battery is connected so as to make it pure electric vehicle. So all these 3 standards are there for the retrofitment. Those are notified under CMVR, and these are India specific standards. There are no international references, and any company who brings out a retrofitment kit can be approved as per CMVR. And based on that approval, that company can convert any existing vehicle with the permission of the consumer, and he or she can operate that converted vehicle on the road. Then coming to the charging station standards, there are 2 types of charging for the electric vehicles. AC charging. In AC charging, we have got a wall box which is mounted on the wall, or a kiosk wherein we get a single phase or 3-phase supply, and there is an onboard charger onto the vehicle, and this electricity supply is supplied to the onboard charger on the vehicle, and the onboard charger charges the battery. So the wall box only provides the electricity, and it meters how much electricity is provided for charging the vehicle. In DC charging, we have got AC to DC conversion happening in the outside panel. So it is a big charging station where AC to DC conversion happens, and the DC output of the charger is connected directly to the battery through BMS, and battery is directly charged. So typically DC charging is the fast charging because battery is directly charged and it can be charged at higher rates. So both scenarios are covered in the standards. So this is how our Ministry of Power has issued guidelines. Recently they have amended the guidelines also, and these are the various connectors and protocols which have been notified by Ministry of Power. For low power charging, like 2-wheelers, 3-wheelers, small cars, we have got Bharat EV Charger AC001, which uses industrial socket IC60309. For DC low power charging, like 48 volt or 72 volt electric cars like Mahindra EV Roto or Tata e-Tigor, these vehicles can be charged with Bharat EV Charger DC001, which is a equivalent of GB by T connector with CAN protocol. So there is a communication happening between car and the charging station. Then coming to the high power charging, we have standardized on type 2, wherein the 3-phase supply is provided through type 2 coupler, and on the vehicle side also there is a type 2 inlet, and the onboard charger which can be 3.3 kilowatt to 8 kilowatt or 22 kilowatt, it can charge the battery. Coming to the DC high power charging, the government has allowed both CCS as well as CHAdeMO. CCS is combined charging system, and CHAdeMO is a Japanese charging system. CCS is predominantly used in Europe, and both are allowed in our country. And CCS is mainly power line communication protocol, and there is a peculiar coupler, and CHAdeMO also a peculiar connector, and it also works on CAN protocol like GB by T. So this is a standardization which has been notified by Ministry of Power. So the charging station can be designed in accordance with these charging protocols, and the electric vehicle also can be provided with proper inlet to charge from the charging station. Now coming to the electric vehicle challenges. Now when we are going to develop the electric vehicle, there are a lot of challenges. One is about electric powertrain development. So we start with how much size of the motor should be used, how much size of the battery to be used, then how the control system development, then packaging of electric powertrain onto the vehicle, and also the calibration of the vehicle on the dynamometer. Then coming to the chassis development, in electric vehicle, battery is a big weight, so chassis has to be a lightweight structure. So lightweighting is a major focus for electric vehicles. Then the structure of the chassis should be suitable to carry the distributed load of motor as well as battery. So that similar separate kind of evaluation of suspension and chassis is required to be done for the electric vehicle chassis. Electrical safety is very important because, as you know, in our country, monsoon conditions, water will be there on the roads, and this monsoon was very tedious monsoon in Pune also, and there would be water problems on the road. So electrical safety from water effects, EMC, electromagnetic compatibility is a challenge for the electric vehicles, and crash also is very important. If there is going to be an accident, how the battery behaves, how the electrical system on the vehicle behaves, whether there is a fire, how the electric vehicle responds to crash like events. So that is also a challenge. Now coming to the components development, uh, although there are less number of components in electric vehicle, but there are challenges for the component development like electric motor. The motors have to be highly efficient, their performance, their durability is important. Then coming to the battery, safety is very important, mechanical abuse, thermal abuse, electrical abuse, because the consumers will be abusing the battery, they will be deep discharging, they will be overcharging the battery. So the battery safety is very important. So battery management system is important, and major concern for the consumers has been cycle life. How much is the life of the battery? Because life is a costly component of the vehicle, and replacement cost of battery is very important. Coming to the charging stations also safety is very important because we are handling three-phase electricity. Those are outdoor installations, so weatherproofness is important. Communication with vehicle is very important. Interoperability, different vehicles, they should be able to get charged from any charging station. So interoperability is important. And rollout in our country, in the absence of adequate space for the charging stations, rollout is also going to be a major challenge. So as I was explaining, in charger interoperability, in short, it is like any vehicle going to any charging station, it should be able to charge. That is called interoperability. And at ARIA, we ensure that we have got a simulator wherein every charger and every vehicle which comes to us for charging, for testing, we make sure that those are interoperable so that any vehicle should not have any problem in charging at any charging station. So to support the automotive industry, component industry, various startup companies at ARIA, we have set up Center of Excellence on electric mobility, and our Center of Excellence works on powertrain, electric powertrain, chassis development, safety, component development, and performance evaluation. And we provide our services and we provide support to the industry in overcoming all those challenges and testing and final homologation. So these are some of the glimpses of our test facilities, like our testing of motors, testing of batteries, testing of chargers, various simulation tools. So these are the various facilities available at ARS Center of Excellence. We have created a separate portal for providing information to the stakeholders about the latest information about the policies, about the regulations. This is the emobility.wri-India.com. It is a child portal of our website, and one can log in to this portal. Similarly, we are developed certain technologies which can be transferred. We are in the process of transferring technology for chargers. Based on our know-how, we have developed chargers which are suitable for Indian standards, and we are in the process of transferring this technology. Similarly, these are the various prototypes of charging stations like low power, DC low power and DC high power. Similarly, we have got prototypes for battery management system. These are the prototypes which we intend to transfer as a know-how to the interested industry. So this is in short from my side. Thank you very much for your patient hearing. And if you have got any queries, I will be happy to answer. Thank you.
Thank you, Mr. Deshpande. That was an amazing presentation, and how beautifully you have, taken us through from all the, like how electric vehicles started in India and what are the government incentives or policies taken up so far, and all the specifications for every segment of vehicles regarding electric vehicles. This is amazing. Yeah. However, we're just running out of time, and we see like loads of questions coming up. So I'm glad that people have been like shooting questions on and on and on, which is great. We will try to publish another booklet based on the questions. So quickly, let me just cover 3 questions maximum. Although we are exceeding out of time, but it's a special topic, and we would like to give the added advantage that you are here. So
Yeah.
I'll ask you the first question. That is, like as EV sector requires close collaboration between testing and certification, agencies working in the areas of like automobile, electricity, information and technology, cybersecurity, etc. So, which are those organizations that are playing a key role in testing and certifications in India? So, if I had to go for like specific things, so what are the organizations taking care of like specific things? So, are there any like information based on that?
Yeah. So presently, there are two agencies which are actively working for the type approval testing of electric vehicles. ARI is one of them, and another agency is ICAT, International Center for Automotive Technology, that is in Manesar. Actually, ICAT is set up under a government's project, NATRIP project, and under NATRIP, government has set up additional centers also, because as you know, India is a very big country. So area is working in the western part of the country, ICAT is working in the northern part. Then there is another agency that is called GR, Global Automotive Research Center, that is in Chennai. And in the central part we have got NATRAX in Pithampur. But the GR and NATRAX centers are still gearing up to have all the facilities and the capabilities to test electric vehicles. But as of now, ARA and ICAT are, I can say, fully geared up to test electric vehicles. In future, other centers also will come on board, and they will be able to provide services to the industry.
This is great. But like, just a follow-up to the question is there any nodal agency in India which is working towards creating synergy between such organizations, for example, BIS, AREI, ICAT, BEE, and, like a Central Electricity Authority, etc. So if we need to go for like a go-to place. So if there is a nodal agency in India, like one place to go.
Yeah, for the as I was mentioning, electric vehicle is a automotive vehicle or a motor vehicle, and all motor vehicles are covered under Motor Vehicle Act and Central Motor Vehicle Rules. And this subject comes under the purview of Ministry of Road Transport and Highways. So all test agencies like ARI, ICAT, GR, NATRAX, they come under Ministry of Road Transport and Highways as far as CMVR is concerned. But Ministry of Heavy Industry has got the FAME India scheme. So this is peculiar or specific scheme for the electric vehicles. So as far as electric vehicles are concerned, for the FAME India scheme, Ministry of Heavy Industry and Department of Heavy Industry is the department which oversees all the test agencies for the FAME India scheme.
Brilliant. So I know there is another question, but just for clarification, you've already mentioned it in your presentation, but just to be clear, again, asking if ARI is dealing with all the testing and certification with issues related to battery charging technology and fire safety. So you mentioned in them, but specifically to these, like includes the whole vehicle, the battery, charging technology, and fire safety.
Yeah, so battery is very critical component of the vehicle, and nowadays lithium ion battery is the state of the art technology which is predominantly used in electric vehicles, because it is lightweight, it is highly energy, it has got higher energy density, and it can deliver the performance required by the electric vehicles. But disadvantage is that high energy density lithium ion batteries are prone to thermal events or prone to fire hazards. So there are quite a good checks or the compliance requirements or in our Indian standard AS 48 standard. And also we are tracking the internet, because internationally also this is a quite a big concern, and international group under GTR 20, Global Technical Regulation 20, the international experts are working on comprehensive safety requirements for electric vehicles and batteries, and we are also participating in those discussions. And whatever final regulation is getting developed, we are also aligning or developing our regulations in line with that regulation.
Okay, this is great. Thanks for explaining it in such a simple and smooth manner. So let us end this webinar for now because we are again running out of time. But thank you, Mr. Deshpande, for explaining us in such details about all the testing and accreditation status of electric vehicles in India, which is really, really beneficial, I think, personally for me, and I hope that the audience thoroughly enjoyed. So we have loads of questions coming from various people at the moment. I apologize that we weren't able to cover all of them because we were paying more focus on letting out the material to the public rather than taking the questions, obviously, which we wanted. But again, we had time constraints. But we promise that we will take all these questions and I'll get the questions from Mr. Deshpande and publish a small knowledge material with all your questions and answers in the same link. We'll be uploading it. Also, I would like to thank all the audiences for joining us today and giving their valuable time and throwing out such great questions and also being so attentive. We hope to see you next time, next month. And I'll be uploading, updating you with what kind of topic we're coming up. If you have any suggestions, please write to me at shravani.sharma.wri.org. As I already promised you in the beginning of the webinar, that you don't have to worry about if you have missed any of the slides or missed out on any of the statements that Mr. Deshpande said, because the good news is we are having the presentation as well as the video uploaded in the same link as you have registered as soon as the webinar gets over. Lastly, I would like to thank our kind funders, the Shakti Foundation, for being so consistent in supporting us throughout these series. So thank you all. See you next month with a new topic again. Thank you. Bye-bye.
Thank you, Shravani. Yeah, thank you.
Thank you, sir. Bye.
Bye.